All right, so yesterday, or I guess it was 2 days ago, we continued our look at evolution, and we were talking about how evolution is the change in DNA over time, which means that the actual numbers of alleles are changing in a population over time. And if that is happening, then the population is said to be evolving. So what you can do is to see if a population is evolving, you can actually calculate and count up the number of dominant alleles, the number of recessive alleles, and you can get what we call the allele frequency, which is the percent of a specific allele in the entire gene pool. So today what we're going to be looking at is actually how to go about calculating this information. All right, so we solved this a couple days ago. So this is just showing you that if the number of alleles are changing in a population, then the population is evolving. And so today we're going to talk about how to calculate that. All right, so here is the first example, and this one is actually all filled in for you. So as you look at this, it gives you information about how to calculate the allele frequency. All right, so it says the frequency of an allele is defined as the total number of copies of that allele in the population. So you could just say the total number of the dominant alleles, so the big A alleles in the population, divided by the total of all of the alleles for that gene in the population. So the number of all of the combined big A's and little a's together. We can calculate population allele frequencies from genotype numbers. So if you look at the top there in the table, you'll see the breakdown of the number of individuals that have each of the genotypes. So again, for the genotypes, you can be homozygous dominant, heterozygous, or homozygous recessive. All right, and the total of all of our individuals, all of the genotypes added together equals a total of 500 individuals. All right, so the first thing we want to figure out is the total of the dominant big A alleles in our population. All right, and it says that this total is 600. Right, now how did we get this number? So to figure out how many big A alleles we have, you need to look at the two genotypes that have big A's in them. All right, and when I look at the genotypes, I can see this is not going to work for me. Get the pen here. It will work. All right, this is working. All right, so we have the genotype there, which is big A, and then we have that genotype there, which is big A, little a. Each of those genotypes have big A's in them. All right, and so if we look at the number of individuals who have big A, there's 180 individuals that are big A. All right, now if you look down here, you'll see we're taking that 180 and we're multiplying it by 2. So why are we doing that? That is because of these 180 individuals, they all have 2 big A alleles. Okay, so you need to take that 180 and multiply it by 2, which is 360. All right, and so that's the number of big A alleles that the homozygous dominant individuals have. Now we also circled up here the heterozygous genotype. They also have big A's. So there's 240 individuals that have 1 big A and 1 little a. Okay, so 240 individuals each have 1 big A. So we don't need to multiply that one by 2 because they all only have 1 big A. All right, and so we're going to take that 360 from the big A individuals, and then we're going to add that to the 240 big A alleles that we're getting from the heterozygous individuals. All right, when we add those together, then we get a grand total of 600 big A alleles in this population. All right, we're not done yet because we still need to get the frequency of the big A alleles. All right, so we're going to take the total of the big A alleles, which is 600. All right, and we're going to divide it by the grand total of all of the alleles, which is going to be, we have 500 individuals. They each have 2 alleles, Okay, so the grand total of all the alleles is going to be 1,000. So 500 individuals each have 2 alleles. So 500 times 2 is 1,000. Okay, so going back down here, we have 600 big A alleles total divided by the total of all of the alleles. All right, and so then that is going to give us a grand total of 0.6. So the frequency of big A alleles in our population is 0.6. All right, if that overwhelmed you a little bit, we're going to do a couple more examples here. All right, so let's look at the next example. So very similar, but just different numbers here. All right, so the first thing we want to do, so we have our breakdown of the genotypes again over here. Oh, it's going to lose my pen again. All right, so over here we have the breakdown of our genotypes. All right, and over here on this side, it tells you how many individuals have that genotype. And then this is our grand total of the entire population. There's 800. Let's just say they're fish. We have 800 fish. All right, the total number of dominant alleles. So we want to count up how many big A alleles are in our population of fish. All right, so again, we need to look at the genotypes that have big A's in them. So we have homozygous dominant, and we have heterozygous individuals. Both of these groups have dominant alleles in their genotypes. All right, so first we're going to look at the homozygous dominant individuals, the big A fish. There's 340 fish that are big A. All right, that means if I was going to draw over here, this is just going to look awful, but if I was going to take the time to draw 340 just very ugly fish that each have 2 big A's in them, and then that would give you the grand total of how many big A's they have. So if I was going to draw all of these out, what you would end up doing is taking the total number of fish and multiplying it by 2 because they all have 2 big A's. All right, so I'm going to take the total of those fish, which is 340, and multiply it by 2 because they all have 2 big A's in them, as you can see. All right, so that is the total of big A alleles that the homozygous dominant fish have. All right, but we also have 50 fish right here that have a big A. They only have 1 because they're heterozygous, but we still need to count those dominant alleles. All right, but we're not going to multiply that one by 2 because these fish, let's look at another ugly fish here, they only have 1 big A in them. All right, so we're not going to multiply that one by 2. So we're just going to take what we already did here for the homozygous dominant fish and add that to the 50 alleles that we're getting from our heterozygous fish. All right, so when we add that together, we will get 730. So 730 big A alleles, that's the total in our population. All right, now we're going to do the same thing with the recessive alleles. So how do we add up the total number of the recessive alleles? Okay, so we need to look at the genotypes that have little a's in them. So again, we have the heterozygous individuals and we have the homozygous recessive individuals. Those are the genotypes where I see the little a's. All right, so the homozygous recessive individuals who are little a, there's 410 of those fish that each have 2 little a's. So I'm going to take those 410 fish and multiply that by 2 because all of those fish have 2 little a's. All right, and I need to add it to the heterozygous fish. There's 50 fish that have 1 little a. So I'm going to add those 50 alleles there. All right, when I add those together, I will get 870 little a alleles in my population. All right, so down here we have the total number of the alleles. So if we have 800 fish, and all of these fish have 2 alleles, whether that's a big A, big A, big A, little a, or little a, all of them will have 2. All right, so we're going to take 800 times 2 and get 1,600 for that. All right, so the grand total of our alleles is 1,600, 1,600 alleles. All right, the allele frequency of the dominant allele. So we're going to take the grand total of our dominant alleles, which was 730, and divide that by the total of all of our alleles, which is 1600. And that will give us the frequency of our dominant allele, which is going to be 0.46. All right, do the same thing with the little a allele. So we will take the total of our little a alleles, which is 870. Okay, and we got to divide that by the grand total of all of the alleles, which is 1600. And we'll get the frequency, which is 0.54. All right, so take a second, make sure you have all that written down. All right, if you have any questions at this time, please make sure you ask, because the next one I want you to try a little bit on your own. All right, so here's another example very similar to the first two. All right, so I want you to pause the video right now and see if you can do this one on your own. All right, so let's check your work. So first thing we're going to do is count up the total number of the dominant alleles. So again, we are going to be adding up, I keep forgetting my pen. All right, so there's my pen. Okay, so we're going to add up the numbers from these two genotypes because they have big A's in them. All right, so remember, our homozygous dominant individuals, big A, there's 45 of them. And each of these fish have 2 big A's in them. So we're going to multiply that by 2. The heterozygous individuals, there's 195 of them, and they only have 1 big A. So we're going to add 195 to that. All right, and what we get for that is a number that I'm going to run out of room, but that is going to be 285. All right, that looks good. All right, and then so to add up the total numbers of our recessive alleles, we are going to do 60 fish times 2, because there's 60 that have 2 little a alleles. And we're going to add that to the 195 fish that only have 1 little a allele. And that is going to give us 310. All right, the total number of all of the alleles. So we have 300 fish, okay, and they each have 2 alleles. So we're going to multiply that, and we'll get 600 total alleles. Total number of all of the alleles, whether that's big A or little a. All right, the frequency of the dominant allele. We're going to take that number that we counted up. So 285 was the number of all of the big A alleles, and divide that by the total of all of the alleles. And we'll get the frequency, which is going to be 0.48. All right, the frequency of the little a allele now. So we're going to take 310, which is the total of little a's in the population, divide it by the total of all of the alleles, and we will get 0.52. All right, so hopefully you did well. Hopefully you got that. If not, again, please ask questions. All right, we have another example here. All right, this one goes over some different stuff. So let me read this to you. It says, a population of mice has 2 different phenotypes for fur color. They are either brown, which is going to be big B, or big B, little b, or white, little b, little b. In this population, there are 720 mice that are big B, little b, 160 mice that are big B, and 120 mice that are little b, little b. Calculate the genotype, phenotype, and allele frequencies in this population. All right, so for these, we're going to calculate 3 different types of things: the genotype frequencies, phenotype frequencies, and then the allele frequencies, which is what we just did. All right, so before we do anything, what I want to figure out is what is the total population of my mice? What's the grand total? So it looks like we need to add up. All right, we need to add up 720, 160, and 120. All right, when we add that up, we get 1,000 mice. All right, we want to then do the genotype frequencies. So how will we do this? We want to look at each number of the mice that have each genotype and then divide it by the grand total of mice that have that genotype. Or I'm sorry, the grand total of all of the mice in that population. So Big B, how many mice had that genotype? All right, so if we look up here, it looks like there are 160 mice with that genotype. So we're going to take 160, divide it by the grand total of those mice, which is 1,000. Okay, and so the frequency of Big B mice will be 0.16. All right, now we are looking at the Big B genotype. How many mice had that? So it looks like we have 720 mice that are Big B. Again, divide it by the total, and we will get 0.72 for the frequency of heterozygous mice in our population. All right, little b, how many mice have that genotype? All right, so we have 120, and we're going to divide that by the total again, and the frequency will be 0.12. All right, so these are the genotype frequencies in our population. All right, so next we're going to be figuring out the phenotype frequencies. All right, so first we need to, before we figure out the frequencies, and we need to know which color is dominant and which is going to be recessive. So the dominant color, that's going to be brown. The recessive color that we see, because phenotype, remember, that's what you see, that's going to be white. All right, so the frequency of the dominant color. So in order to answer this, we need to figure out, well, which genotypes are brown. So we have Big B, little b, and little b. Those are the three genotypes. Out of those three genotypes, which ones show the brown color? Well, that's going to be the ones that have at least one Big B in them. So these two over here, Big B, and Big B, little b. All right, so Big B, and Big B, little b show that brown color because they have at least one Big B allele in them. All right, so to figure out the frequency of the dominant phenotype, we have to add up the numbers of mice that have these genotypes. All right, so that's going to be 720 are Big B, little b, plus it looks like 160 are Big B. All right, so when we add that together, we get 880. All right, and we need to divide that by the total of all of the mice, which we said is 1,000. All right, and then that will give us the frequency of mice that are brown. And then that will be 0.88. All right, now we need to do the same thing with the white mice here. All right, so which genotype shows the white color? That's going to be the little b. All right, so how many little b mice did we have? Okay, it says 120 up there. So 120 divided by 1,000 equals the frequency of the mice that have white fur, and that's going to be 0.12. All right, so these are phenotype frequencies. You're counting up the frequencies based on the color that you see, or whatever trait you're looking at for that word problem. All right, finally, we're going to be going back to the allele frequencies. All right, so the total number of alleles, that's the first thing you need to figure out. So remember we had 1,000 mice. Each of these mice have 2 alleles. So those alleles could be big B, big B, big B, little b, or little b, little b. No matter which of these genotypes they have a grand total of 2 alleles. 2 here, 2 here, 2 here. They all have 2, no matter what they are. All right, so we're going to take the grand total of mice, multiply them by how many alleles they each have. We'll get the total of all of the alleles, which is 2,000. Okay, so that number goes there. Right, calculate the allele frequency for the dominant allele, so B, and then the recessive allele, little b. All right, so which genotypes have a big B in them? Okay, so we have big B mice and big B, little b mice. Both of these genotypes have a big B in them. All right, so how many big B mice did we have? Okay, so it looks like we have 160 mice are big B. Okay, so since they are big B, that means they all have 2 big B alleles. So we have to multiply that by 2. 160 mice each have 2 big Bs. So we have to multiply it by 2. All right, we also have these 720 mice that each have 1 big B in them. Okay, so we're going to have to add that to 720 mice that each have 1, so we don't need to multiply that one by 2. And when we add that up, we get 1,040. All right, and to get the frequency, we're going to divide that by the total number of alleles, which is 2,000. Okay, and the frequency we will get is 0.52. All right, now we're on to the frequency of the little b allele. Okay, so we're going to change colors. All right, so we have 120 mice that are little b. So 120 mice each have 2 little b's, so we have to multiply that by 2. Plus those 720 mice that each have 1 little b, so 720 equals 960 divided by the total of all of the alleles together. Okay, when we divide that out, we'll get the frequency of the little b alleles, and that will be 0.48. All right, so that was a lot of stuff. So for this question, we had to calculate the genotype frequency, the phenotype frequency, and the allele frequency. All right, so make sure you have all of these notes written down. If you miss something, if you are just still confused by how something was done, please go back and re-watch whatever part you need to go over again. All right, so now I want you to try some on your own. So you have a paper that says relative frequency at the top. It says practice in the top right corner. It is very similar to the last question we just did that talks about the mice. The first one talks about birds, and then the second one talks about crocodiles. So please do those on your own now. Show all of your calculations, and if you have any questions, please raise your hand and I will come help you.